Hello, YouTube. Hello, Nathaniel.
Hey, how's it going?
Hey, it's going really well. Thanks for being here on the live stream at the moment, on the podcast very soon. After everyone out there watching, thank you for being here. If you got comments, thoughts, throw them out into the live chat. We'll try to make them part of the show. If you're watching later, of course, thanks for being here, but no live comments in the past. All right. And with that, let's kick it off, huh?
Sounds good.
All right. Nathaniel, welcome back to Talk Python to me.
How's it going?
It's going real well. It's going real well. We're on the eve of PyCon. How about that?
Square. Okay. Yeah.
I don't know how many eve. Maybe it's the eve to the third, but we're very near PyCon. I'm pretty excited.
Yeah. Anti-penultimate eve. I don't know.
The penultimate eve, perhaps. Yeah, exactly. Yeah. So I suspect a lot of people will be listening to this show on their way to PyCon. So if you are, awesome. Come say hello to me. I'm going to be doing some live shows, some Ask Me Anything, some various other things. Are you going to be at PyCon this year?
I'm not, unfortunately.
So they're going to have to just shoot you a message on Twitter or on Mastodon or something like that, right?
Yeah, I'm easy to find. GitHub, email,
yeah,
whatever. Yeah.
Yeah, excellent. Cool. Well, everyone going to PyCon, hope you have a great time, and do come say hi. And with that, we're going to be talking about this project, this new PEP about distributing Python itself, kind of like you distribute Python packages, but a little bit more. Why not? I mean, it seems pretty reasonable to me, and I'm super, super excited to see you work in this area because Python is so strong in so many areas, and there's just a couple of like really big gaps that other technologies have nailed so well. Two of them that I see that are super significant is like, hey, Michael, I want to build a mobile app. How do I do that in Python? Or I want to build a desktop app. How do I do that in Python? Like, I'm not sure. I'm not sure you should even think about doing like desktop, maybe mobile. I mean, Kivy is great, but it's not like a general purpose UI toolkit. And so that's the one. The other is, hey, I have an application. I want to give it to someone who is not a developer and have them run it. Right. And there are some tools that address that. But one of them is just like, oh, how do they get Python at all? And your project, your PEP, and some of the ideas relate specifically to how do we make it easier to get a pre-built, non-admin, not install for the whole system Python for somebody so they can run an app, or even for developers, right?
Yeah. I mean, in fact, I'm a developer, so that's kind of in some ways the original use case, scratch your own itch.
Yeah, of course.
That, right?
Yeah.
But yeah, I mean, it's a very general capability, I think, once you have it. So yeah, I mean, the motivation there is basically like, there are lots and lots of ways to get Python, right? You can get it from, the Windows Store. It comes with pre-installed on your Mac, but not a very good one.
Not quite, sort of.
There's, but there's also Homebrew or PyEnv, or your Linux distro has it. And you can, get it through Conda. And if you download Blender, oh, there's secretly a Python inside. Like it's just, there's just so many different ways to do it. And that's great. Like it's good to have all these options. They all serve different use cases. But it's sort of silly that, it's obviously, it's flexible. There's lots of ways to do it. That there's no way to just be like, okay, like I just want a zip file that has Python in it. And it's like a standard way that's like supported and, kind of we all use so we can all sort of share benefits and improvements and all of that. So that's kind of the key, the PEP is not that innovative in terms of what it's actually, doing, right? It's a zip file with Python in it. But it's just sort of trying to do kind of the logistics of like, okay, but like, let's all agree on how we're going to put it on PyPI. Let's, have tags and stuff so tools can figure out what they're looking at and do stuff automatically. And I think that unlocks a lot of use cases, just that one simple change.
I think it does as well. I mean, your abstract is one of the more concise ones, I would say.
Sure. Yeah.
Tell people about the abstract here.
The abstract on the PEP is it's quote, like Wheels, but instead of a pre-built Python package, it's a pre-built Python interpreter. That is the full abstract. I figure that basically, tells people what they need to know.
Yeah. So the idea is kind of like you would say pip install request. You might say pip install Python 3.11, except for that you can't use the word pip because pip is built on Python. And so you need Python to run. I mean, it's a little bit circular there. So you kind of need something outside of Python. But conceptually, it's I have these things I need to run my app. I need request, SQL Alchemy, and Beautiful Soup. I also need Python 3.11. So those are my dependencies. Give me that, right?
Yeah. And I mean, you could even imagine potentially pip install Python 3.11 working, I suppose. Like you would need some Python to run pip, but once you have that, then it's probably still convenient to be able to say, okay, actually, shoot, so I got this bug report saying in 3.11.2 specifically, there's some issue, and I'm not sure if I can reproduce it. Like being able to just grab that in one command, pretty useful. But that said, it's not necessarily, pip isn't necessarily the target. I've been working on some stuff there as well. I don't know if you want to get into
yet. We'll definitely get into it. We'll definitely get into it. I think, you need something a little bit on the outside. And I think ideally it doesn't depend on Python being on the system, because it would be perfectly useful for it to depend on Python.
Right.
And this gives you a different version. This gives you a way to quickly toggle between these versions and these different setups. But if you could omit that dependency on Python, then all of a sudden you give a way to give it to people who are not developers, in use cases where it's not just I already have Python and I need to do. Maybe you're a developer, but you're not a Python developer. Should you have to manage your own Python installation so that you can use something that needs Python to run against your source code, right? That is not Python. So there's a lot of scenarios where I think it gets unlocked if you use a different foundation.
Yeah, I mean, one of the audiences definitely have in mind here is like, people with like taking their very first ever programming course on the first day of class. Like right now, it's pretty awkward that you're like, okay, well, first you have to go to python.org and then click through here and click there and download that. Oh, wait, no, not that version.
Right. Oh, did you forget to check to put in your path? Oh dear. Hold on.
Yeah, and oh no, do you use the Pi launcher? Are you on Windows? Are you like it's this extra fiddliness. And it's funny, we've spent all this effort in the last few years kind of getting wheels to the point where they can just work, right? You can just pip install NumPy and it works everywhere, stuff like that. But Python itself isn't there yet. Another use case I've sort of maybe my primary use case, sort of audience I have in mind is, right, I develop Python packages and as open source and distributed on PyPI, stuff like Trio. And so I have the problem of, I want to be welcoming to new contributors, right? I want to, bring them in, get them started first quickly. They're volunteers. So like, I don't want them like faffing around and struggling and getting stuck trying to just like run the tests or anything like that, right? Like both that's just a waste of time. It's like kind of rude and inconsiderate. And it's also, there's likely they'll just give up, if it's just a casual, like, they aren't really invested yet. It's just something they're doing for fun or out of interest. I really want to, make that easy for them. And so part of the vision here is like, be able to say, oh yeah, so you check out Trio, here, you type this git clone command, and then you have, some kind of Python management tool installed. And you type that tool, run tests, and it makes sure you get the right version of Python and set up the environment correctly. And then it executes it for you. And it knows what tests are, how to run the tests in this project as it looks at, I don't know, pyproject.toml or whatever. Right. And so just sort of capturing all, we have all those pieces, but we don't really have anything that kind of brings them all together into that, like just type one thing. That's it. It's going, and it just works.
Yeah, we don't have many, we honestly don't have many tools that are outside looking in Python. So much of our tooling in our infrastructure is you have Python. Now you start with the tools. Now you install it. Now you install Black or Rough or other.
Yeah, there's just this kind of very old assumption, which, I mean, it made sense like 10, 15, 20 years ago, where sort of everything was sort of installed manually. And of course you're going to go through some work to like get it set up with Python. It's the foundation of your whole environment. And then we add stuff to make it easier on top of that. But kind of, I think it's time to kind of go back and reevaluate that sort of foundational assumption.
Yeah,
Yeah.
absolutely. So you mentioned Trio. I know before we dive too much further in, I want to give you a chance to kind of
Yeah.
let the folks know what you're up to. We'll talk about Trio at the end if we got time. But, what have you been up to since June 29th, 2018? 5 years ago, roughly.
Right. Last time I was on the podcast.
Yeah,
right?
last time you were on the show.
Yeah. Wow, that was really early in Trio's life, I guess, actually. So I mean, I've had a lot of just real life has happened. I was sick for a while and trying to kind of get back on my feet. Did some consulting. Just started a new job, so it's kind of a lot of distractions, but also yeah, I think Trio is still I still like it a lot. It's definitely had more influence. Actually, had I even published the structured concurrency blog post then? I don't remember.
I feel like it sounds familiar to me, even though it's been 5 years. It does sound familiar. So
Okay.
I do think so. But what has happened since then certainly is Python has seen some of these ideas and adopted them, right? Like 311's concurrency stuff.
Yeah. So there's been sort of the influence has got a lot further than I ever expected. Both actually in other languages. So like Swift and Kotlin, and have all kind of adopted ideas from here. Java apparently is making some big changes coming up soon with a whole new concurrency setup, and they're like saying like, yeah, we're basing it on that Nathaniel Smith random blog post. It's kind of like, okay, yeah, sure.
Oh, interesting. Okay, amazing.
Okay, it's very flattering. But yeah, and yes, also in the Python itself, it's sort of complicated because it's sort of this awkward situation where there's async.io that's in the standard library, and then there's my sort of competing thing, Trio, which we guess we should say Trio is an async library for Python that's portable. It's sort of an alternative to async.io. There are some tools to kind of let you use both at once, but it's not a library for async.io. It's its own thing, and so. Like obviously we all wish there was just one obvious choice. I kind of looked, but async.io is also in this very difficult position being in the standard library and being sort of built up over time. And a lot of it was designed before we even had stuff like async.await. So there's just a lot of machinery in there that's kind of already committed to other ways of doing things, and it's very hard to change. And Trio was sort of like, well, look, we have all these modern things, add some new ideas coming in, like structured concurrency is a better way to kind of write concurrent programs. And it was able, since it had a clean slate, to like really, do that all from the start and be much simpler. So that was important, to have it be its own thing, just so we could, work that stuff out. Then there's a question of, okay, now what? Do we all switch to Trio? Do we move it back into async.io? Do they both continue?
That's been a debate for some really popular things. I think that is interesting. A lot of people say, well, why is library X, which everyone uses, why is that not built into Python? Why do I need to pip install it? And a lot of times the answer is because making it part of Python will harm its ability to innovate and change.
Yeah.
Right. It'll slow it way down.
Yeah. Like there was a whole debate some years ago about like we all know the HTTP client in Python, urllib or whatever, is just really bad. You should just never use it. And it's broken in a lot of ways. Like you just don't use it. But we still ship it because it would be too disruptive to take it out. That's also why we can't change it. There's just too much code out there depending on all the weird quirks. And we don't want to ship something else because then it'll end up being urllib 5 years later. So we it was questioning like, should we put requests in the standard library or urllib3 or what, one of these? And it's just, then you can't ship security fixes. You can't improve your API. You can't, so as we've gotten better at packaging also, it's taken some of the pressure off the standard library to be all things to all people. And I think that's kind of a good direction overall to be moving as an ecosystem.
I agree. But, when the standard library first came into existence, there was no PyPI and there was no package. Like it had to come with it because how else are you going to get it hunt it down on Usenet and on, base 64 and code it and put it in, like, what are you going to do?
Yeah, or I mean, maybe you find you download, I don't know, Twisted or something like from an FTP site.
Yeah, or
And
an
you have to
FTP site or something
manually
like that. Sure.
unpack it and have to put it in your pipe. Like it was all totally, yeah, knocking rocks together, sharpen sticks.
Hope it's flint and it creates a spark.
Yeah.
So I think the motivations and the decisions, the way you might lean in making those decisions are really different now. Like I would, even though we're already far down the road and making changes is breaking and doesn't make sense, it might make sense to ship less in the standard library, quite a bit less, and just say, oh, you're going to pip install some meta package that explodes out some section. I'm going to pip install the collections area. Boom. And now I got a bunch more.
Yeah.
Potentially. Who knows?
One thing I'd really like to see as a possible sort of future there is moving some of the standard library into wheels that are installed by default.
Yes, exactly.
So
yes.
That's sort of this halfway house, right? Where, it's still the case you download Python, install it, they're there. So we don't just like break everyone in the world who just assumes they're there. But then it kind of gives us that both of, the long term, if it's like we want to get rid of it, it kind of gives us, or push it out to PyPI or just remove it entirely. Then it gives us kind of a way to do that more gradually. But also for, libraries like async.io that are big and complex and really, would benefit from being able to have their own release cadence and bug fixes and deprecation cycles and all of that. Then it's like, it still ships with Python, but then you can pip upgrade it. You're not stuck with that exact version that could only change when a whole new Python release comes out, and you have to take all those changes together at once.
Yeah, I've absolutely had this thought, and I think it's a really elegant solution, because on one hand, it lets the core developers focus more on the true essence of Python, and it lets it be used in more locations, right? Think PyScript, for example, or MicroPython, right? It might be that you could create a central core that is exactly the same on all of these. You don't have to consider, like, of course, this is what runs. It runs everywhere. But you still get that backwards compatibility, and you get the ability to say, actually, I want the newest version of async.io because I want this more high performance background worker or something.
Yeah. Or even just, I mean, for smaller, like, I don't want the newest version of async.io because, like, I don't know if it works, but I want to install in a Scratch environment this like development version so I can try it out and give them feedback before they, make the release and set the API in stone. And again, like right now, like you'd have to go build your own Python, and it's like it's just kind of a whole thing, right? You can't just do pip install -- pre.
Right, exactly. It's definitely more of a barrier for people who are just casually wanting to test stuff out. You got to be pretty committed to getting Python 3.12 alpha 6 or whatever we're at, right? I don't know. Yeah. Indeed. Okay. Very cool. Maybe we'll come back and dive into Tree a little bit more, but yeah. And so what are you doing these days? You talked about doing a little consulting and
so I just started at a new job just like last week before, I guess. Yeah, it's been less than 2 weeks.
Exciting.
I'm working at Anthropic, which I don't know if anyone's heard of. It's still somewhat stealthy, but it's sort of
less now.
I mean, quickly changing. I don't know the exact status currently, but yeah. So my understanding of the background here is that there's actually the team at OpenAI who trained GPT-3. Sort of, sat down together and thought, decided they really wanted to do more of like a pure focus on like interpretability and safety of like, how do you get these models, like, how do you know what these models are actually going to do, and how do you get them to do what you want, instead of kind of, stuff like making things up or just, we've all kind of got the scene now how these large language models can go just all over the place, do all kinds of strange things. And they decided
there's even one of them being sued for slander, I believe.
Yes. Okay. Yeah.
By somebody in the UK, I think.
Yeah. Well, yeah, there's one that just like, if you ask the model, like, can you give me some advantages of like, problems with sexual harassment in law schools? And it just picks like 5 real law professors and makes up stuff. Like it's really, really bad. Yeah. And it like cites sources that are all made up. Like it's, they're just they're very powerful, but also not
Yeah.
well understood, or how to like kind of make
They,
them useful and safe and all of
just
that.
a little bit of devil's advocate though,
Yeah.
they are incredibly powerful and they are incredibly capable. And that's, I think, part of the danger is you're like, oh my God, it knows this. Oh my gosh.
Yeah.
Look, it understood all of that. And I ask it. So the fifth thing it says, you're like, well, at this point, I'm convinced. It really
Right.
is on.
Yeah.
And then maybe that's the made up one. And I think that's the danger, is because it's actually, it's almost an uncanny valley. It's close enough to right
Yeah.
that you're like, okay, this thing's right. It knows.
Yeah. So yeah. So personally, like I'm still kind of up in the air on how how impactful they'll be, where the impact will be. Like I think there's just a lot of open questions.
You haven't
But
bought a farm, like a goat farm in the woods, because you've just given
no,
technologies
I
a
haven't.
blowout now. Okay.
Yeah.
All right. Good to hear.
But I guess I do have stock options now, apparently, or I will at some point if they vest. So I guess that's the other route. But no, but anyway, so I was just saying, so yeah, so Anthropic's just interesting company where, you know, you actually get to play with some of those big models internally. They're kind of working on releasing products now. But it's also been kind of just really interesting to kind of get the sense internally of like, it's really kind of this like research culture, which is appealing to me. I'm sort of coming out of academia, of a lot of like numerics background. And what's also is interesting is that part of the reason we kind of, you know, connected is that apparently, you know, turns out a ton of their internal infrastructure runs on Trio. So they're, you know, partly hired me to support that, and are actually giving me time to work on open source paid time. So actually they are funding this PEP 711, you know, Python binary stuff, though they don't know it yet.
Now they do.
Yeah, if they listen to the podcast, they'll learn.
That's great. That's really cool. It looks like an interesting area to be working. I agree that the research-oriented places, they are fun area to work, right?
And there's just a lot of flexibility, kind of, you know, like it's clear this stuff is going to have effects. Which effects and how big and all that, I don't know. But, you know, being at ground zero is, you know,
it's exciting.
It's really exciting. Yeah. And a lot of chance to maybe have some impact. So
cool.
Yeah.
All right, let's dive into the PEP. The PEP. That is,
okay.
it's not quite PIP, but it's kind of like PIP. Okay.
Yeah. Okay.
So we talked a little bit about the motivation. We talked a little bit about what it is. Maybe tell us a bit about the spec. Like, what does the PEP actually say? What is it actually trying to deliver? And we can talk about like the use cases and some of the tools for it and so on.
Later. Yeah. I mean, and so like I said, you know, that the abstract deals like wheels, but it's an interpreter instead of a package. That's partly just sort of a tagline of like how you use it, but it's actually also a lot about how the actual spec is written. It's just sort of a like, well, you know, we've done a ton of work over the last, you know, 5-10 years. A lot of people have put a lot of work into making wheels work, right? In terms of like figure out, okay, how do we, you know, have metadata that's usable to like keep track of, you know, which packages are installed and their versions and which ones are compatible. And for a binary build, like which systems can you put this on, and, you know, all the many Linux work and just all of that stuff. And it's just like, well, you know, so we have wheels. We don't need to reinvent the wheel again. So I'm just sort of taking all of that. So it's just like, okay, you know, it's mostly, it's just a delta against the wheel spec. It's like, okay, in the wheel spec, you have, you know, this directory for metadata. I have, you know, that same directory, but I calling these Python binaries PyBis, just to have sort of a short name. You can stick in a prefix, or sorry, in a file extension.
Yeah, PYBI.
Yes.
.pybi. I like it. It's
the PyPI, the interpreter, and PyPI, the package repository, were confusing enough. So I thought I'd add another near homonym to the
PyPI. It's PyBi.
Yeah,
Gotcha.
you know. Anyway, but so like, but they look like, you know, the file names look like wheels. Like, it's, you know, be something like, you know, CPython -version -many Linux 217.pybi. They context looks like wheels. They're basically just zip files. There's some, you know, instead of a .distinfo directory, you have a PyBiinfo directory, and it has a metadata file that's in the same format as wheel metadata files for the name and version and, you know, description, all that stuff. There are a few tweaks, basically just what you need specifically for interpreters. So okay, so like one thing that makes it a lot simpler is that there's only one interpreter in a Python environment, right? Whereas wheels are kind of designed to be flexible and be installed into different kinds of Python environments with different layouts. A PyPI is just it's just a raw set of files. You unzip it, that's it, you're done. Where wheels, there's like, well, okay, if you want to put this in site packages, so you have to go find that. Whereas this goes in the bin directory, so you have to go find that and do the special, So that part's just, not relevant. We leave that out. There's some slight, we have to support symlinks, which wheels don't. Mostly just because there's never been a big compelling reason. What's that?
For the Windows folks out there, maybe, and others who just haven't paid attention. What the heck are symlinks?
Yeah. Okay. Well, so symlink is a classic Unix concept, though Windows does have them too now, I guess, where it's like a special magic file that instead of having like its actual contents, it just says, go look at this other location on the file system for my contents.
Right. It's like an app shortcut, but
but like
programs, not for UI.
Yeah, well, like built into the file system, though.
Yes, exactly. So you try to open it goes to the other one.
Yeah, the operating system automatically opens that other file for you. But you could also like look at, if you can like say like, can you show me the symlink, and like it'll tell you about it if you ask. But if you don't, then it just magically works. And it's mostly it turns out that traditionally Unix Pythons tend to use these both for things like in your bin directory, you'll have the Python executable, and then you'll also have Python 3 as a symlink to Python, and Python 3.11 as a symlink to Python 3. And so, wanted to preserve that. And also, it turns out on Mac OS, they have this very specific kind of layout they want with like framework. Like, I don't really understand it in detail, but like there's sort of like how a Mac OS app is supposed to be structured, and that it turns out to involve symlinks. So we just have to support. That said, I mean, the way we support them is like, it turns out there's a standard way to put them in zips. So I say, let's do that. Like, again, really trying to keep this as boring as possible. And then the last thing,
you could have a symlink in a zip file. That's crazy.
Yeah, it's an extension from the InfoZip folks, but then it's because I don't know. Zip's a strange format. It's kind of like an oral tradition, as much as like an actual like specified format. But
there's an entire documentary on zip. And
oh, really?
I believe the guy who came up with it. It's even controversial in its early days. It's nuts, but it seemed to have won the compression de facto standard these days.
Yeah, it's definitely got trade-offs, but it's just in terms of it's just really useful, just a thing that everything could understand. Yes. It's just so compatible, and it's also
so much better.
You can do random access, unlike some of the alternatives. You can pull out one file from the middle if you want to.
The fact that anyone can open it is so much better than it might save 1 more percent. Yeah, for sure.
Yeah.
Cool. Okay, so we've got these. Basically, the PyPI file is the zip file. Is that basically the entire interpreter just kind of bundled into a zip file? Like, what's the deal there?
Yeah. Okay. I mean, it's just literally like, you install Python into a certain directory, and then you take that directory and you put it in a zip file. There's a little bit of tweaking to like make sure it's self-contained and you can move it in a portable, relocatable, I guess is a better word.
Yeah.
So sometimes if you just install Python regularly, it's kind of will have hard coded. I know that I'm at this particular position on the file system, and so I need to make sure we don't do that. And also to make it self-contained, it's like the same thing we do with wheels. Like you have to vendor some libraries, right? If it wants to use readline as a library to for like in the REPL to be able to like edit your line as you're typing it, then we can't just assume it's on the system. We have to include that inside the PyPI.
Right.
So but again, like this is stuff we've all already dealt with wheels. There's tools for doing it. We understand how to do it, and I'm just reusing those tools. So
if I were to run a Python application delivered by one of these PyPIs, does it have to unzip the contents into a location and then run it there, or can it just run it straight out of memory, or what? How does that work?
Well, so by itself, the format, I mean, it's just a zip file, right? So you can do what you can do with a zip file, which I mean is not much on its own. You need some software to work with it, right?
Yeah.
Now that said, I think so. Yeah. So like if you just were starting with nothing and you're like, I have a URL to a PyPI and I want to use it, then you'd have to download it, run it on zip tool, and then you could go into that directory. It's a Python environment. You could run pip in there or whatever.
Okay.
That said, I think this is a really useful building block for tools that want to go beyond that. So things like delivering a pre-built application that you can just run without unpacking. Like there are various tools to do that, like PyOxidizer, Py2App. I don't know. There's a ton of them, actually. I'm probably forgetting like 10 more.
Yeah, the ones that come to mind for me are Py2App, PyInstaller, and PyOxidizer for sure.
Yeah.
PyOxidizer being the newest of them.
Yes.
Yeah.
Oxidizer because it involves Rust somehow.
Because all the new things involve Rust.
Yes. But yeah, so those tools that it's really useful to be able to say, okay, like I'm going to do some clever thing to like set up, I don't know, a self-extracting executable or whatever it is they do for their distribution mechanism. I'm going to create an installer program. I'm going to whatever it is, but you still need an actual Python to put into that, right?
Yeah.
And so having a straightforward way where it's okay, that's not their problem anymore to figure out how to find a Python and get it built and working for the target system. So they can just say, okay, I can just like grab, okay, yeah, you want to target, many Linux, cool. I'll just go grab the right Python. It's already there. I know it works. And now I can take the files out of this PyPI and do whatever I want with them. I can pack them into my installer or do clever things to make them usable out of memory or whatever. And they can focus on that part instead of just the like, how do you even get a Python?
Yeah. Or how do you, once find yourself in the wrong Python, get the right Python potentially?
Yeah.
Even, yeah.
Yeah.
That's I don't know if that's trickier or less tricky, right? It's one thing to say, dear user, go get Python. You need that. It's another thing to say, go upgrade your Python and hope you don't break something. I think. Yeah,
well, but also that's part of the point of these being self-contained is, so I mean, this is one of the more trivial use cases, right? But right now we all use virtualenvs, and mostly that's fine. But also sometimes, they can get, janky stuff can happen. Like, you're on Linux, you do an apt upgrade, and now your system Python's changed, and all the virtualenvs that were based on it are broken now because it like had some kind of dependence on that exact binary. Now, I'm not saying you would always want to do this, but at least it's nice to have the option. You could say, okay, instead of making virtualenvs, I'm just going to make real envs. They're all just going to be, I'm just going to drop a new copy of Python in each environment. And that way it's totally self-contained. I know exactly what I have. It upgrades when I decide to upgrade it. And it's just, it's a nice option, right? Sometimes to have that. And also, it gives you that total isolation, right? So then we were just saying about that issue of like, oh, I wanted to use this, so I went and upgraded my Python, but now that other thing I was already using broke because they're using the same Python. It's like very easy to say, no, just give them different Pythons,
There's not that much that changes over time. That's a backwards breaking sort of thing. I mean, 2 to 3, but I think that's let's put that in the past. But
that's a whole.
But I did but I did recently. I was working with MongoDB using Beanie, which was using Motor, which was using the @async or @coroutine decorator, which was removed in 3.11 or 3.10, one of those recent upgrades. And it had been deprecated forever. The people at MongoDB said, we don't care. We're just going to leave it. Who wants to put the word async in front of my method? That's tricky. Right? I mean, they just probably weren't paying attention.
Yeah.
And my code wouldn't work. I'm like, why doesn't this work? Oh, the thing I depend on, which the thing it depends on, that thing needed less than 310 or whatever, 310 or 311, whatever.
Yeah,
but
and now we're back
to
real CKO struggles to
and
adapt
so
without breaking. But
stuff like this
it does happen,
and this kind of isolation gives you 100% confidence to say, I'm going to make this new app. We're going to try running this app on this in production, and it's not going to hurt anything. And I don't need Docker.
Yeah. And you can say, or you could say, I'm going to, use this exact point version in development, and then I'm going to take that and build it, use that to create my Docker image. Like I don't need the like pre-built Docker stuff. I could just grab Python from PyPI, and I know it's the exact same version everyone else is using, built by the Python.org folks. Hopefully, we're not there yet, but like that's kind of where we're trying to.
That's why a PEP and not something on GitHub, right?
Yeah, sure. Well, it has been on GitHub for a while, but I have time to kind of
Yeah.
move
So
it towards
maybe
the
it's worth jumping over that. But before we do, 2 questions,
Yeah.
maybe
Sure.
2 top level questions anyway. So this is about the concept of kind of like pip install Python 3.11
Yeah.
or 10 beta 2 or whatever.
Whatever it is. Yeah.
Yeah. Is there a way to say, and these 3 packages off of PyPI? Like, can I take and kind of
Right.
bring a virtual environment effectively along with me with what you're doing so far?
So, okay. So PyPI is, again, by themselves, I mean, it's just an archive format, right? A package format. It
Right.
doesn't do anything. That said, obviously, yeah, part of what we want is for these to be useful for things like, building environments that have other packages in them and stuff. So that's the one other thing I didn't, I forgot to mention about defining the format. Probably the most interesting part, actually, is that we do add some new static metadata that we put into the package. And kind of the motivation there is that I try to figure out, okay, what do I need to know in order to install wheels into this Python without running it, right? Because right now, right, like pip assumes that it's running on the Python it's installing into. So anytime it wonders, like, okay, like what ABIs does this Python support, and what version is it, what platform am I on? It can just ask the interpreter it's running on, right? And it's like, okay, well, it would be really nice if you didn't have to do that, both for like efficiency, like you want to be able to, figure out which, have your like installer, your resolver, figure out which versions of everything it wants without having to like download and run multiple versions of Python and stuff. Like, you'd really like to avoid that. It's also things like I want to build I want to build, release distributions for, Mac OS, but I'm on Windows, or vice versa. Or I just want to, I'm developing my package like Trio on Linux personally, but I would like it that when I lock my, version, so I know all my, collaborators are using the same versions, that we figure out locks that also work on Windows and Mac OS. And I can't just trivial run all those Pythons, from one resolver, because it's not running on all 3 at once. And we, and Python packaging does have the ability to like have different dependencies on different OSs, and it gets kind of, can get very kind of complicated to figure out like which packages do I need where. And so I want to put a bunch of metadata into the PyPI, like all the stuff you need to solve those problems. So the PyPI itself, I think normally they won't ship with any packages. Maybe, again, call back. Maybe in the future we'll start moving some of the standard library into wheels that are pre-installed. You could do that. But I'm guessing, like, for now they'll mostly just be, a plain vanilla Python install. But then you could take that, you could take some wheels, bundle them all together into a new archive if you want, or again, whatever you want to do with it, stick it in a Docker image, whatever.
Yeah. So it's a step towards, but not necessarily trying to propose an entire solution of, here is the interpreter and all the dependencies and the code, and just run it as if it had no dependency on your system. Just treat it as like a .exe or a .app. I can just double click.
I mean,
and make it go.
It makes that a lot easier than it is
yes.
Right. Like right now, first step is just to figure out, like, how do I even build a Python that'll work like that? And that is like some arcane dark knowledge written on a tome in, black ink on black paper and a black tomb you have to go find, or something. Like, it's just, it's not easy. And so just having the ability to say, like, just grab this file, unzip it, drop some wheels in it, zip it up again. Now that's a package you can hand to someone and it'll work on their system. Like that makes it a lot more accessible.
Sure.
It's not the thing I most personally like. I'm not immediately going to go build that one last extra tool, but I bet someone will.
I can imagine someone will, for sure. Okay. My next question is not what on our shared screen here, but is what impact do you think this would have on PyPI? First of all, do you see PyPI the way the CDN that delivers packages like Trio and wheels like Trio? Do you see that as the same channel through which CPython 3.11 is delivered?
Yeah, I mean, so I would like these to literally be like you go to PyPI/project/CPython. It says like here's
Yeah.
the latest release, and you click on downloads, and it shows you the. Yeah, I'd like it to just literally be stuff you upload to PyPI.
Right. And when you pip install from there, it figures out the platform to pick from, and it downloads that wheel,
Right.
and off it goes. Right.
Yeah. I mean,
Do you think that would add like a huge burden to the amount of traffic, or do you think it would be okay?
no. I mean,
How large are
obviously
these
we'll have
things?
to see and adapt, but Python itself, it's like it's tens of megabytes.
Okay, so there's
So
plenty of other
there
packages
are a
that size.
lot of much bigger, like go look at TensorFlow or something. Um, there are hundreds of megabyte packages on Python that are very popular. Also, I mean, Python.org downloads go through the same CDN anyway. It's just
Right.
sort of different infrastructure on the back end, but it's still fastly serving it and donating the bandwidth. So, in that regard, I wouldn't expect much change. And also just, like people tend to install, wheels more often than they install Python, right? Again, it's
Mm.
hard to know sort of the second order effects. Like maybe virtual lens will be less popular in favor of full lens if this takes off. And then
Yeah,
people
that's what
start
I was
installing
thinking, kind of.
Python
Yeah.
more than they do now. But still, nonetheless, I don't think it's, a huge, I wouldn't anticipate it being a huge change. And if it,
Okay.
it turns out to be a problem, then, we can kind of address it then,
Well, you could also do, to a large degree, you could do like just already that caches.
yeah,
You could just cache the C Python wheel, the PyPI into the
yeah,
user profile, and the second, third, fourth time you get
yeah,
it, it's really the CI system and all the dockers and all that stuff that don't understand what a cache is or any of that, right?
yeah. But then, so like if it becomes a real problem, then, you go to GitHub and you're like, hey, can we work something out so that, you stick a cache in front of PyPI?
Yeah.
And, like
Yeah.
stuff like that. Like it's not, trivial, but, you can talk to people and solve problems. Like I don't think we should, hold back the entire design of like how we distribute Python and make it available because maybe it'll be too easy and people will use it too much. Like, like that's a good problem to
They
have,
use
right?
it. Yes, exactly. Look, they're using it. This is terrible.
Yeah, like first you make it easy to use and then figure out how to solve any problems that causes. Don't.
Yeah, I think we've more than once solved the problem of, oh my gosh, they're using it, like Google,
Yeah,
Netflix, you
yeah,
name it.
yeah.
Think of the benefit though you'll be doing for all the developers, especially those who have Python skills and are looking for a job. I mean, if the popularity of Python by downloads is one thing, if you could like 4x that, we'd all be more demand. Like,
Right.
look, it's really, really downloaded now.
Right. Yeah. Just go out there and just download it 5 times in every CI job. Just,
Exactly.
throw 4 of them
Just
away,
do it
but
twice. Just do it a couple times. Just show.
Right. Yeah.
Awesome. The question that you put into the PEP here on the screen though is why not just Conda? And I, not being a particularly data focused person, I definitely prefer using pip over Conda because especially it seems like a lot of the web packages are not as close to up to date. There's a latency before it hits Conda and it's like immediately on pip. That said, there's a bunch of people who are like, I kind of use Conda for this.
Yeah. Yeah. And right. If you're just like, look, I don't really care about all this. Like, I just, want to run my Jupyter notebooks and I, just need a Python that can do that. And maybe, some NumPy or whatever. Conda solves that really well. And this thing could, I'm working on could also potentially solve that really well. And so it feels duplicative to those people. And to them it is. It doesn't really, they're both two solutions that work, but there is a necessarily reason for them to choose one or the other.
But this could also be a foundation for the way that Conda provides Python to itself.
Maybe I don't know. Like, there's a whole other question about how like we could bring Conda and PyPI pip, that kind of world closer together and interoperate better. But it's sort of that's a whole like can of worms, lots of complicated stuff. I don't think this. I don't think this PEP itself is going to be the thing that makes a big difference there.
Okay, but it's not an anti-Conda type of thing.
No. Yeah. Well, and so I mean, you can also see a version of this in the PEP, but like basically the way I think about it is that the key reason why we just why PyPI is a critical piece of infrastructure that cannot be replaced by anything else is not because it's of its use for end users. I mean, it's great that end users use it and find it helpful and all that, but like that isn't the people who absolutely need it and could not have any replacement. The reason why we just absolutely need it is for package developers, because the way, again, you're talking about all those different ways you can get Python, right? And there's all these different ways Python packages get distributed, right? You can brew install Python packages. There's versions, NumPy, a patched version of NumPy used to be part of the standard macOS install. Maybe it still is. I don't know. Like when you install Blender, there are Python packages in there. If you install some game using, was it RenPy? It's going to have Python packages in there. Or just, there's so many different ways that Python code goes out in the world and gets used in all these different contexts. And if you're developing some upstream library, like Trio again, or requests or NumPy or anything, then what you absolutely don't want to do is have to maintain a separate distribution for all of those different things. You don't want to have to upload your package to Conda Forge and also to Debian and also to Fedora and also to Blender Forge, or like you just like that doesn't make any sense, right? So we need this, and then having every different package maintainer do that, like that just would be terrible, right? You just would be unworkable. So the critical role that PyPI serves that just nothing else can is it's this intermediation point between package uploaders and package users, including package redistributors. And so like I make a release of my package, I upload it to PyPI, and then that's where Conda Forge gets it, that's where Debian gets it, that's where end users get it if they're pulling straight from PyPI. Like sort of it fans out from there. And the key difference in terms of design between pip and Conda is that pip's metadata formats and wheels and the metadata and source disks and all that are designed around this abstraction of you have some kind of Python environment, but it could be any of those, right? It could be on different OSs, it could be different ways of building it, different layouts, different pieces could be missing, like whatever. Hardware. It could be laid out in all kinds of different ways. I just know that there is some kind of Python environment, and I have the metadata to like figure out how to adapt to how this particular Python environment is put together. And Conda, on the other hand, is one of these sort of downstream systems. The reason people like love it and like data science, right, is because it's a full-fledged like arbitrary application distribution thing, right? You can install random C libraries, and you can install R and R packages. Like it's got compilers. They're all there in the one thing. But because of that, it isn't have this abstraction of I can handle any Python environment. A Conda package, a Python package, is set up to install in a Conda Python that's laid out in the way a Conda environment is laid out, in the way that using the libraries a Conda library has, right? And so it doesn't have that flexibility. If you just release something for Conda, then it's great for Conda, but it's not usable to Debian and Homebrew and all of those other folks. And so like sort of that's the key thing that PyPI does, right? Is like it has that abstraction that lets you you kind of have the Python packaging ecosystem of all those packages and their dependencies on each other, and then you kind of project it down into each of these more specific specialized packaging systems, right? And then also because that's the other thing. As a package maintainer, I don't just write my package and upload it. Like I'm also using all the other open source maintainers' work as I do it. We're all working together, right? And I'm depending on their work and they're depending on mine. And so I need to be able to say like, okay, my package needs those 3 other packages and here are the versions. And I need to be able to download, create an environment with those versions and test it before I upload my package to PyPI. And so again, all that work has to happen at that higher abstraction level. Like you can't just say, I'm going to take the latest version from Conda and test against it, because that's not necessarily the version that other people will get. Where you take the versions from PyPI, those are like the original ones. I have access to anything anyone has ever uploaded as soon as they upload it, and I can test them all together. And then, if Conda wants to take some curated subset of those or whatever, that's great. That's a really valuable service. but they kind of need that underlying set of packages to curate, and that's what
Yeah,
PyPI
that's
is
true.
for.
And
Yeah.
PyPI is kind of the definitive source of truth as
Right.
the package creator intended it to be.
Yeah. And then of course, yeah, for a lot of end users, it turns out that just going straight to that without any intermediary works great for them, and that's really, really cool. But also, it's not like I don't have anything against people who prefer to go through Debian or Conda or whatever. I think that's also great, if that works better for you. But for the folks who are developing packages to upload, or who just would rather just get stuff straight from the source, the PyPIs I think can solve a lot of problems that Conda just doesn't address those. It has a different focus.
Right. Trying to make it swap over to do that might kill a little bit of what it's it's good for,
Yeah.
Yeah. All right, let's see. So let's move on to your announcement here. I think.
Okay, right. Yeah.
So over on discuss.python.org, when was this? This was January 21st. So this is a few months ago. You announced PyPI and Posey. And
yes.
And Posey we talked about this mythical pip that could pip install CPython 3.11. Posey is that mythical pip, right?
Yeah.
In a sense.
So the pip 711, the PyPI stuff is just the one brick in my master plan. So right. Because sort of this vision I had in mind, I kind of alluded to earlier, talking about like, okay, if somebody does, git clone my project, I want them to be able to just run the tests and know that they have the right version of Python and the right version of the dependencies, and it just kind of, and they know how to run just do it, right? Encode all that information somewhere. And Posey is sort of my experimental, it's not ready to use, but it does have a lot of stuff working, is my attempt to solve that part of the problem. So the vision is Posey is a full reimplementation of pip, the like metadata parsers and dependency resolvers and archive installers and all of that, except I rewrote it all in Rust, as is the style. But it also it's all built around PyPIs, so it doesn't. I mean, maybe at some point we'll also start supporting VNs or user installed Pythons, but for now, sort of for the MVP, it's just says like, okay, yeah, you have a PyPI, I will grab that, I will grab packages that are compatible with it, I will arrange them all to run together based on you just say what you need, I turn that into like a lock file, I fetch those packages, I run your test script or whatever. And yeah, I mean that is the core idea. And one advantage of being in Rust is that it's just becomes just so obviously if you want to hack on it, then you need like a Rust compiler and stuff. But if you just want to use it, then we can just we can compile it down to a single binary that you just upload to wherever, install it from wherever, and you drop it on your system, you run it, and it's self-contained. It can handle everything from there. So again, thinking of that target audience of like beginners, right? You say, okay, install this one program, and now you type, Posey run, and oh look, you're in a REPL. And it's like, and now internally, of course, they had to go find the latest version of Python and grab it and figure out which build is right for your system and do that. But you don't have to think about that. You just hit enter and it happens, and there's your REPL.
Right.
Or they say, Posey add requests, and then, or Posey add Jupyter, and then Posey run notebook, and it kind of is handling the environments behind the scenes.
That's I talked. Yeah, we did a panel discussion with a bunch of core developers around packaging recently, and a lot of them were saying things like, I don't really want to put words in the mouth, but kind of getting the sense that like, okay, so we have a bunch of tools that are really neat that live within Python. I'm thinking Hatch, Poetry, those, that category of tools, pip itself even. And some of the challenges or problems that they would like to solve, they could unlock a simpler API if it was turned inside out, right? If the tool itself controlled Python and didn't depend on Python to get started, they mentioned Rust up as a way to get started, which is a way to kind of install a version of Rust and get started, right? And it feels to me like this is pretty close to that.
Yeah, there's a lot of overlap for sure in terms of sort of the goals and approach and all of that.
So one challenge I see is, like, for example, to run the application with the Python that's bundled up inside of one of these PyPIs is you would say Posey run or Posey some kind of file or something like that, right?
Sure. Yeah. Whatever.
Exactly. Yeah. Whatever the CLI that's yet to be fully spec'd out comes out to be.
Yeah.
But could you do things like, could you create, speaking of Simlinks and other types of stuff, could you create just in the same folder where that app lives a Python that actually just calls Posey the Python inside instead of Python itself, and pip that says, Posey run pip inside this Python to kind of bridge to unify the API from where people are coming from, to kind of expose the same tools that are inside a little bit. You know what I mean?
Well, so yes, I mean, so the way I am currently sort of in my current prototype, basically, it doesn't work like that just because it felt sort of more complicated to then like try to expose those things. So sort of the sense is like, let's see how far we can get with treating sort of the UI paradigm of like Posey is just your front end to Python. Like you start your command with Posey and that's the only command you need to know, kind of. And that also allows some interesting things. So like the way Posey does environments right now is you can have multiple environments within a project. Like if you need to test against multiple Python versions, or you need different installs for, I don't know, tests and for building your docs and whatever. But it doesn't actually materialize all those as separate independent virtual environments. Instead, what it does is it for like each unique wheel or PyPI that it needs, it unpacks that into its own directory. And then on the fly, it assembles environments by like setting up environment variables so that it can launch a Python in such a way that it picks the right Python and launches in such a way that it sees the right packages it's supposed to see. But there's only one copy of those packages on disk if you have multiple environments. If you want to like try out, different versions or whatever, it can just sort of like do that without having to go rearrange everything on disk. And that's just, it's convenient. It's just a really nice way to work with it, sort of having declarative Python environments. So you never update an environment in place. There is no environment in place. It's just on each command you run, it sort of knows declaratively, okay, these are which packages are supposed to be there. I'll give you those packages. So there isn't even a concept exactly of like pip upgrade or pip install. You can just say that next time I invoke environment, I'm going to give you a different specification for which versions I want. And it'll make sure that happens.
Feels a little like Docker, right? Like if you create a Docker image and you run a container, you want to make changes to it. You don't log into the container typically and mess
in
with
that
it
sense,
on the
right?
command line. Yeah, but you would just say, okay, well, we changed the Docker file, we shut it down, and we start it back up with the new, better version of itself, right? That sense, I mean, it's like Docker.
Yeah, the main difference, a big difference would be that Docker. Then when you build it, like the actual Docker file is this big old imperative: go scribble here and then delete that and then put something else, that kind of thing. It's not so like here's the list of things you need.
Well, it feels to me like maybe a better solution than what Docker is giving you. If what you really just want to do is run an isolated Python thing repeatably, because with Docker, the idea is like, well, you want it isolated. So let's do this. Let me give you an entire separate copy of Linux.
Right.
I know it's running it in like not a full VM way, and it's not as heavy as a VM, but it's still you're configuring a Linux computer inside of this container in the way whereas this is just like, I just want Python configured, not everything.
Well, and even more like in Docker, if you want to make sure that you run Docker build twice and get the same package versions, like you have to do that yourself. You have to use, I don't know, pip compile or something, like create a lock file and then install from that instead of your original requirements. And, it's a whole thing. There's lots of ways to get it wrong. Whereas in Posey, the way I've written it currently, it's just like there's one operation, one internal function that takes a set of like, okay, these are the packages I want, and it like renders that down into a lock file of like, here's the exact set of packages you need, including all the dependencies and all their versions. And then that's the thing that you hand to the run me an environment thing. So like you have to go through that step. It's just built in. And so we can like, so, and of course, as we build up the, CLI and stuff, the idea will be that will be then, written to disk, similar to a cargo.lock or poetry.lock or whatever. And so you just automatically get that reproducibility, which, you don't get that automatically from Docker. Right.
Right. Nice. So this is a thing that people could go get under on your GitHub profile. They could check this out and they could try it, right?
Let's see. So obviously there's a lot of moving parts here. If folks want to help with the PyPI part, the PEP 711, there's lots of stuff could use help with. But it is also, there's a draft PEP up, and I have built lots of PyPI packages for lots of different versions of Python for Mac, Windows, Linux. They're up on a CDN. If that uses the same API as PyPI, so you could pip install from there if you had a pip that did it. So it is stuff you can try out right now, experiment with at least. And then as for the Posey part, again, like I said, it's mostly the backend stuff, but it is a pretty complete implementation of like all the packaging stuff. It can actually do that demo I was just saying of like, I need these 3 packages in this version of Python, and it can do the dependency resolution for a named specific operating system, which may not be the one you're running on, and then generate that environment and actually invoke it. You can only invoke it if it's for the operating system you're running on, of course. But it can do all that stuff. There isn't really a UI in front of it yet, so it's not like something I'm suggesting you go start, rolling out to your company.
Everyone adopt it,
but
your DevOps story,
if this is like an exciting project for you, then you could check it out, see where it's at, join in, whatever. There's definitely tons of stuff to do, but it's there's a good solid start. And I think it's, at this point, I'm pretty confident like everything could work, right? Kind of the proving it out part is pretty much there, done. So,
question from Marwan in the audience. Hypothetically speaking, does a Posey.lock work as is on different platforms?
Right. Yeah. So cross-platform support is a huge issue with locking. I don't know if anyone's ever tried to do this with like pip compile. Like it just doesn't work. If you have anything complicated, like multiple Python versions, like it just doesn't work. Good. They tried hard, but yeah. So what I'm doing right now in Posey is I've tried to kind of keep it simple. I just say like, tell me which platforms you care about. Resedish Linux and Windows 64 and Mac OS, ARM and Intel or something. You'll give me like a list, and then it can go through, just like loop through that, and for each one, find the right PyPI, look up the metadata to figure out which kinds of packages are appropriate to install there, and generate a lock file for each of those. And then you can somehow like merge the common parts and write them to a file. So the individual things that like resolve this set of versions or set of package requests into a exact set of versions, that only runs for one specific platform at a time. But you can run it multiple times. It might be possible to do something smarter. So I know like Poetry has some algorithm that I don't really understand very well, where they try to sort of simultaneously resolve all the platforms into their log file. And then the way the log file works is then it's like only like mostly resolved. And then when you actually go to install, it does like that last step to try to narrow it down to the exact platform you're on. And no one's been able to explain to me yet how exactly that algorithm works, or even like I'm not 100% sure it's even like if it's fully correct or if it's heuristics based or what. So I don't know, but like we can change. There's lots of options, right? We can change the code if there's a better way to do it. Just that's where I'm at so far.
But so there's something people can play with, but it's early days. And you wouldn't mind having help if people wanted to jump
no,
in
for sure. If you've been looking for an excuse to learn Rust, if you want to play around with cool, I mean there's interesting problems terms of things like how you efficiently resolve do package resolution is like this whole messy like logic programming problem. It's MP complete. There's just like interesting system engineering problems of like, okay, if we're going to really make this really nice to use, like you want it, like how do you unpack 20 wheels as fast as possible? You get to use threads and concurrency and all kinds of stuff. There's lots of cool technical bits too. And of course, just making something that's like a joy to use, fits nicely in your hand. Lots of fun user interface problems. Yeah. I'm excited about it, if you can probably tell. Like I just love these kinds of problems. So yeah,
absolutely. So this announcement was on discuss.python.org, and I thought, okay, well, it says there's 72 responses. Let me flip down and see how this landed with people, right? Like,
okay, yeah. Okay. A wide variety of responses.
Yeah, well, but I mean, I would say that at least the top batch, the first bunch of people, Paul Moore, deeply involved with PIP, jumps in, says, this is beyond awesome. I hadn't realized you were working actively on this. I'll take a look. I'd love to help out too. Talks about Rust a little. Frederick says, really nice to see this. This is a great direction. Honest says, well, certainly blew my mind. Count me in on how we could explore how this might work for Conda and so on. And just, I thought it was really, really quite positive how many, next person, this checks many of the boxes of what I have in mind. So it seems like it's landing well with the community. I hope that it continues to make good progress.
Yeah, I think the biggest thing is like there were definitely some folks going like, okay, but why are you writing everything in Rust? Like, especially it's like, we've spent a lot of effort not just making standards for Python packaging, but also like implementing those. So like you can pip install packaging and like right now, and that is a library that can do things like unpack wheels and access the PyPI, or I forget exactly which set, but like a lot of the tricky stuff, parse Python metadata formats and, just all these different tricky things. And it's like, why are you re-implementing this? And also, does it like send the wrong message that like, when we wanted to do something complicated, we thought Python wasn't good enough. And we needed to switch to Rust. And I get where they're coming from. But, well, I mean, there's a few things. So one is just that I thought writing in Rust would be fun. I'm not telling you can't use Python for anything.
Sure. I mean, well, let's take a step back and say, how would you propose writing that in Python?
Well, so
if there is no Python, right?
That's no, it's possible, right? So like, Conda's written Python, right?
Okay.
And the way, so it makes the distribution a little complicated because like when you get your conda.sh or mini conda, like the installer, it has a Python package inside it, which it unpacks and then uses it to run Conda to install like another Python or whatever it is that you want to install with Conda. But it sort of has one built in. And you could do the same thing for something like Posey. That's
use something like PyInstaller to build an executable.
Exactly. But then for PyInstaller, effectively, right? Like, just kind of recursively do that. It's totally something one could do. But the main reasons I'm not to go that way is one is, like I said, like it's just was more interesting to me. It's one thing. There's also like, every language has trade-offs, right? And the exact set of things you want from a package installer are kind of right in Rust's sweet spot and not Python's. So there's sort of 4 things that are really important for a tool like Posey. So there's the initial install, there's the how quickly it starts up, because like this is in between you and invoking Python or whatever it is you actually want to do. There's how quickly it can resolve packages, and how quickly can it unpack packages. Like those are the things that you care about. Like those are the big load bearing pieces. And those are like kind of 4 of Python's weakest spots, honestly, right? Like, so like we just talked about the deployment part. You can make it work, but it's not as straightforward as some things. There'd be more possible moving parts, things that could go wrong. It's not the strongest argument, but it is there. For startup speed, just notoriously one of Python's weak spots because it has to like do all those imports from scratch every time. Tools like Mercurial have struggled with a lot. Lots of Python applications, doesn't matter, but for this particular one, That would be a challenge. And then resolving is big, heavy, like that NP complete, like just really gnarly, burning as many CPUs as you can on complicated logical operations. Again, not Python's strongest point. It's not something you could like use NumPy for, and it's not like IO bound or anything.
Yeah,
like it's
you
just,
could use something like Python potentially, use a no-GIL
yeah,
operation. But at the
right.
same
But
time,
then you're basically be writing it in C at that point, like the core logic.
You're pretty far from core Python there anyway.
Yeah. And then finally they just, unpacking files is totally IO bound and so simple that it's actually a big advantage to be able to like IO is so fast these days with like SSDs and everything and NVMe drives that like almost any overhead in the unpacking path actually is pretty substantial as a relative proportion. So like you add like one Python operation per 100 kilobytes written, and that might suddenly be like a 2x slowdown, just because everything else is so fast that even that small amount of Python overhead could be large. And in a tool like this, like people are really sensitive, like they really care if it takes 10 seconds versus 1 second to unpack those the environment. Like that's just a huge difference in usability. So I think it's kind of really it just happens to be an exact combination of things that makes Rust pretty compelling. But you could do it the other way too. It's not. Sure. I'm not making it isn't meant as a political point.
It's just, okay, got it. Python is written in C.
Yeah, sure. So except PyPI, but
I mean the core, the core bit of it is written in C, right?
So PyPI is written in Python, right? Hence the name. So,
yeah, that's true.
Yeah, but yeah, C Python written in C. It says it right there.
Yeah, exactly. Okay, interesting.
Yeah.
I think we're probably out of time to dive much further in this, but
sure. Yeah, I think we covered a lot.
I think we covered a lot. I guess.
Anything else you want to
give me your thoughts on the future? Like, what do you think? Is the PEP gaining traction? Right, this is in draft mode. I don't know how much I emphasized at the beginning, but it is not an accepted.
Yes, that is important to be clear on, though. Yeah. It's just where is it? I wrote it. I posted it for feedback. That's as far as it's gotten. There's no commitment on anyone's part to like that this is what's actually going to happen. That said, I'm pretty optimistic. Like I said, I got a little bit of pushback on the Posey part because of like the Rust and whatever, but I don't think I've gotten. I can't think of really like any pushback on the PEP 711, the actual PyPI part, except people are like, well, but why aren't you using Conda or something? Which fair question, but there's an answer, and I don't think anyone like it's not something that like the people that you need, whose agreement you need to get this accepted, are like the PyPI maintainers and Python packaging maintainers, and they are totally okay with like Conda's not the solution to everything, obviously, right?
Right, sure. Well, how complicated to fit Conda into this particular use case, right?
Yeah, I mean, there's definitely room to collaborate better there, and I would love to see that in the future. But my sense is that there's just really hasn't been a lot of like people just seem pretty much like, yeah, this is cool. I guess actually the biggest thing is that there's been some feedback from folks like the PyOxidizer folks saying like, hey, we would like a bit more metadata so we could fully, dissolve some of our other things we want to do. Like we want to be able to cross compile for a given Python, and we need to know a bit more about the target Python in order to do that. So that's just a very technical. Okay. It's like, more stuff we should add and tweak. But the core idea,
the idea, that's just like
I think the basic idea, generally people seem to be on board. I'm not going to make a commitment to what like Python.org and PyPI and all they're actually going to do, but I'm pretty hopeful. I think that they're definitely some of the folks involved in like building the Python.org downloads right now are like, oh yeah, I'd build one of these if that was standard, sure. So it isn't all signed off on and full, but there seems to be a pretty reasonable consensus that like this is a good direction that we're interested in moving in.
Cool. Well, it sure caught my attention when I saw it, so I'm excited.
Thanks for having me on to talk about it.
Yeah, you bet. No, let me just ask you real quick the final 2 questions, since it has been 5 years since I asked them of you.
Okay.
When you write some Python code, you work on this. What editor are you using these days?
I am using Emacs, same as I've been since I was 13. So
All right, right on.
that's not a political position. That's just I'm stuck.
You like
You've
all
used
your
it for 20
commands to
years.
come in chords, right? Okay, got it.
Like that's it. Yeah.
Excellent. And then notable PyPI package.
Just some
Something
random
cool.
PyPI package I
Yeah,
like.
just something you like ran across. This is
Anything.
awesome. People should know about this. Could be very popular, not popular at all.
Oh man, shoot! I did not prepare for this. Should have. I mean, I don't like. There's some obvious, like obviously, I like trios. Been thinking about a lot, but that's not an interesting answer for this.
You mentioned rough earlier.
I think you mentioned rough, but rough is pretty cool.
Maybe I didn't mention rough. Yeah, okay.
Rough is very awesome. If anyone doesn't know, rough is sort of Flake 8 and such re-implemented in Rust, so it's like 100 times faster. Like you just like instantaneously lints all your code, which is very sweet.
It is a selling point for Rust integrated with Python, right? Like another use case that looks pretty neat.
Yeah, and I sort of as I'm digging into it, I'm really impressed at how those two how well they fit together. People put a lot of work into like making that really smooth and having them collaborate well. Actually, it's something I've just been working on at work is we've been having trouble with in an async library like Trio, you have lots of tasks running concurrently, but they only like the scheduler only gets to switch from one task to another when one task explicitly lets go, like says, okay, I can stop here. We're using an await statement. So it's possible to write code where you accidentally like don't do that for a long time, and that task will just like hog all the runtime and block other tasks from running. And it'd be nice. It's hard to kind of tell when that's happening. And a similar thing could happen with the GIL. So if you have like an extension library like PyTorch or something, and they forget to drop the GIL before doing some big heavyweight operation, then it could just block any other threads from running. That's really awkward. We've been having trouble with that, and but well, like PySpy, that's another really cool package. If anyone's seen it, is a Rust profiler for Python that can just sit outside your process and can like give you tell you what it's doing, but also it being in Rust and it's up on crates.io, I could just write a little program that imports PySpy and uses it as a library, and tweak it so that instead of looking for like where's code spending time, it detects, okay, is something hogging the GIL or the run loop, and give me the traceback, show me which code is doing that.
Yeah,
and it's again really neat to be able to get that really deep insight into this Python stuff that we're still we're using it. It's still Python, but the Rust really is a great flavor that goes with it.
Cool. PySpy. All right, people can check that out. That's sampling profiler for Python programs.
Yes, yeah.
Excellent.
PySpy is really cool.
Indeed. All right. Well,
okay, cool.
Thanks for being here. If people are interested in the PEP, what should they do?
I mean, I guess the post on discuss.python.org is the best place for like feedback. It's also where I posted about Posey. So if you want to like see the discussion or join in, that's a good place. If you want to like help, then github.com/njsmith/Posey is the repository. Jump in, send PRs, file issues, whatever, or just send me a I don't know. Yeah, what's the tweet@me? I guess the Mastodon version. I'm not really on Twitter these days, but yeah, njs@mastodon.social.
Excellent.
Cool.
All right. Well, Nathaniel, thanks for being here. Thanks for this PEP. It looks interesting.
Yeah, thanks. It's great being here.
Yeah, you bet. Hey, real quick before we call a wrap on the YouTube channel, let me just ask a follow-up real quick with one question. This guy Diego, it says, "I'm in academia and consider leaving for the private sector. Was leaving academia easy? Do you miss anything about it?"
Oh man, this is a big thing. So I did not leave academia voluntarily. I left academia because I got very ill. I have ulcerative colitis. It's one of these autoimmune things. Basically, yeah, my immune system decided my large intestine is evil and should be destroyed. And basically, it is a thing about academia. There's many things I love about it, but it is a very sort of intense, like you can't, you basically like there is no place in that. There is just no long-term place in academia for someone who isn't able to work like 60-hour weeks. and just like really be grinding away. And that is not compatible with being really sick and needing a few years to like figure out treatments and just all of the stuff I was dealing with. And so it was messy and complicated, but like, I ended up leaving academia because of that. And now I'm kind of getting back on my feet and trying to get back into academia as a whole thing. And it's like, well, I'm not sure I really am able to get up to that grind. And also, I'm just in a rough position after being ill for so long and all that. So I don't know where the future will lead, but, I don't know. Academia's, there's a lot of wonderful things, and there's kind of some brainwashing while you're in it, right? That like, this is the best, everyone kind of reassuring themselves is the best.
Of course you want, like, who wouldn't want to be here, right? Like, this is fantastic. We're the best.
There are all these unique advantages too, but there are other options. Life is not over if you leave academia. There are lots of wonderful options.
I left way earlier than you. I left in the middle of my PhD program. And the one thing, asking what did you miss? I thought I would miss teaching people because I got to teach, calculus, linear algebra, stuff like that. I do that every day.
Right.
Like, I do the podcast. I do that with I talk Python training. I make courses. Like, there's room for like that kind of stuff, and all the freedom to explore and move and change jobs more than once every 5 years. There's a lot of advantages.
One job in the world.
Exactly. There's 3 job openings in the world. I apply for them in September. I get notified in April, and I get them in the next year. Like, that is a crazy delay in opportunity to move around. And you don't have that as a straight up developer.
And I think that's a good point, that like there are a lot of opportunities for parts of the stuff that are great about academia if you can find them. So like you were talking about education, but also like realistically in terms of impact on the world, my like theoretical work in my blog post on structured concurrency is probably much larger than my papers. I have some well-cited papers, but it's kind of within one niche. And like that's just a blog post. I mean, there doesn't even have an OID or anything, but
the true impact is pretty big.
It may well be what I'm remembered for or something, like it's just,
who knows? Cool. Well, thanks for sharing that. And I'm glad to see you doing better.
Yeah. Thanks a lot.
Yeah, cool. Thanks again for being on the show. See you later.